The survey should have found something. Wise scanned hundreds of millions of objects across the infrared sky, hunting for one signature, heat that a star couldn't explain. A Dyson sphere, if one existed, wouldn't stay invisible. It would glow in mid-infrared, waste heat leaking out from an engine built to capture a star's entire output. The catalog came back almost silent. That silence is the case file. The logic behind the search looked airtight. Thermodynamics guarantees waste heat. Any civilization capturing stellar energy on a planetary scale has to dump the leftover as infrared radiation. Freeman Dyson proposed exactly this in 1960. Don't look for radio signals. Look for the glow of industrial exhaust. Wise and Spitzer took that idea seriously, scanning tens of millions of galaxies and stars for infrared excess beyond what starlight and dust could produce. A few candidates surfaced, each one, on closer inspection, reduced to something ordinary: circumstellar dust, star-forming debris, instrumental noise. No structure, no megascale engineering. So the conclusion followed the usual pattern. Giant artificial heat sources are rare or absent in our observed volume. But that conclusion assumes something the data doesn't actually prove. It assumes an advanced civilization radiates heat the way our models expect it to. Here's the crack. Waste heat isn't fixed. It's a design choice, and thermodynamics rewards a very different design than a glowing sphere. A civilization optimized for efficiency wouldn't leak uniform infrared across a wide band. It would emit narrow, structured, low-entropy heat, the kind a survey isn't built to separate from a cold dust cloud sitting at nearly the same temperature. Unexplained excess and boring foreground dust can look identical from Earth. The physics gets colder from here. Computation has a thermodynamic floor. The Landauer limit sets the minimum energy needed to erase one bit of information, and that minimum scales with temperature. Run your thinking at 3 Kelvin instead of 300, and the energy cost per computation drops by 2 orders of magnitude. Some physicists have proposed that any civilization with a billion-year time horizon would eventually migrate its computation toward the cosmic microwave background floor, not because that environment is hospitable, but because it's cheap. That reframes the whole search. A civilization at 3 Kelvin isn't dark because it's hiding. It's dark because efficient thought pushes toward the same temperature as empty space. To detectors tuned for objects tens or hundreds of degrees above the cosmic background, that signal looks like no signal at all. The temptation is to say, this proves cold, quiet civilizations are out there. It doesn't. The data can't tell absent apart from undetectable by design. That gap is the real mystery. 3 explanations compete for the silence. The boring one. Megastructures are simply rare, because building anything at that scale is harder than the thought experiment suggests. A more interesting one: civilizations pass through a brief, loud infrared adolescence, visible for a few thousand years out of a possible billion, and Wise happened to be looking during the quiet stretch of that timeline. And the frontier explanation: technological maturity trends toward the Landauer floor as a general rule, which would mean the galaxy could be threaded with old, cold computing civilizations that no infrared survey is sensitive enough to pick out from background noise. None of these can be ranked with confidence yet. That's the limit of our observations, not a failure of the search. Wise and Spitzer were built to find thermal excess above the general sky, not narrow signals buried inside a noise floor shared with natural dust. A phenomenon sitting just a few Kelvin above the cosmic background lands exactly where our instruments are weakest. The next generation of mid-infrared observatories exists to close that gap. The Habitable Worlds Observatory, the life mission concept, and targeted Juist-Meary follow-ups bring finer spectral resolution. Tools built to separate structured, low-entropy signals from the smooth thermal signature of dust. If the silence is real, they should confirm it more precisely. If it's an artifact of searching for the wrong phase, these are the first instruments with a real chance of finding the alternative. The Fermi paradox has always assumed a civilization loud enough to build eventually gets loud enough to be seen. The Landauer limit suggests the opposite. Intelligence, given enough time, trends towards silence, not through collapse, but through efficiency. If that's true, the galaxy's quietest volumes may not be its emptiest. The honest question the next surveys have to answer isn't whether anyone is out there. It's whether we've been listening for a sound that any sufficiently old civilization eventually learns to stop making.